actually answered some questions from the Check Your Understanding in fourth block. So I put together the video from this class and that class because I recorded the questions that they asked. And specifically, Jeremiah Beverly, we have another Jeremiah in that class. Oh, we did? We don't anymore. But Bev, just clarifying for anyone who didn't, Bev actually had questions from the Check Your Understanding, and he was able to get those questions answered. If you attempt the Check Your Understanding, I can answer those questions because you've already attempted it. You check your answers and you know what you get right or wrong. So please keep that in mind. You can tell you wait, Coriana. And Finney, you need this. And you've been gone all week, right?
No, Monday, Tuesday. Well, 3 days.
Yeah, so all week. Yep, basically. And you need this, and there's one more thing I need to find for you. Okay. So here's the Check Your Understanding that you missed that I passed out yesterday. It's for 3 different sets of ideas. And here, let me hole punch this for you. And this is the lesson we're about to work on. Okay. There you go. All right. So, yeah, please ask those questions. What all is on the DWAD, by the way? Don't forget, guys, when you ask questions, it needs to go at the end of that sentence. Question mark. Come on. Oh, Mr. Kenny, we're in a math class, not an English class. They're all connected to each other. We got to be attentive to the details. All right, trying to help you grow. So, what we're going to start with today is collecting data, proper inferences, and I'm going to answer your question in just a second. So, collecting data, all about proper inferences, okay? So, what are the 2 type of inferences we we want to make in studies? What are the 2 types of inferences we're trying to make? So that's a type of study, okay? So remember, so we have our types of studies. Hold on to what you just said, I just want to clarify. So we have our types of studies, which the types are experiment and observational study, okay? What do you mean, oh Lord, like, you don't know that we've been studying this for 3 weeks now, 2.5. Experiments and observational studies are 2.5, not fully 3 weeks. Okay? But what are the types of inferences we can make? And Rihanna, I think you said one. We can make an inference about the population, but which of those types of studies does that typically go under? Observational, right? So an inference about the population. But what's the thing that prevents an accurate inference about the population?
Bias.
Bias. So we got to reduce those things. We got to know how to reduce bias. We got to know how to recognize bias. So what is the type of inference we're trying to see in an experiment?
Causation.
Causation, right? We got to know that. Now we'll point out that means we can see correlation in an observational study. Right? So inference about population, inference about causation. And so, what's the thing that causes us issues in an inference about causation? Say letter. Confounding, right? Okay. So we got to be aware of those things. And I want to point out, like, legitimately, I know some of us are like, man, Mr. Kinney, why should I care about these things? Just yesterday, a colleague of mine here at Hillcrest, because I don't know if y'all can tell, but I have slightly different opinions or ideas about how we can and should do education. Hopefully we're picking up on that. And this colleague sent me an article that talked about how we should put students in rows, because when we have students in rows, there is less distractions and students get off task less and there's less behavioral issues, okay? And so there was actually an experiment. So could they establish cause and effect within that experiment? Yeah, they did a random assignment to these treatments of the desk being in rows or desk being in groups. And I haven't gotten a chance to talk to this colleague yet, but I'm going to, because I want to talk about it, because I very much disagree. So first, there's a couple of issues, right? So when you see claims, you need to be able to know how to investigate. So the first issue I saw in it, first off, it was from 19 years ago, almost 20 years ago. maybe the data is still valid, but I can tell you this right here and right now. The way that y'all operate as students is different than the way my generation operated as students, and so we can't make the assumption that what worked 19 years ago works today. So problem number one. Problem number two, the sample size was only 3, which means there was a little bit of what in the experiment, but probably not enough of.
Yeah.
Maybe data, but there was a term we learned yesterday for experiments. Look at your proficiency scale. There you go, Chelsea. Look, the sample size of only 3. I would say that that's not enough blank. No, Chelsea, yellow proficiency scale. There's a term on there.
Oh, okay.
Experimental unit.
So there weren't enough experimental units. I would agree with that, but that's, so what do we do with those experimental units? We apply treatments, okay? But what is it called when we apply those treatments to lots of experimental units? Say it again. There wasn't enough replication in my opinion. That could be a fluke, right? So I see a problem in this study design of, okay, there's not enough replication here. There was not enough assignment of treatments to experimental units. Another issue that I had with the study design is it was only done in classrooms where there was a known, what's the term I'm looking for? Behavioral problems, right? Not just general education classrooms, not the typical classroom, but specifically where there was behavioral problems. Well, can I make an inference about all classrooms off of a group of classrooms that's just behavioral problems? No. See, like there's lots of things when we say, hey, here's this data, here's this study, we need to be able to investigate and say, but is this valid? Is this fair? Is this accurate? The other issue, and the biggest issue, is the cause and effect they established was between sitting in rows and just time on task and behavior. But what's the priority for my classroom?
Communication.
Communication to drive what? Learning and thinking. If you're sitting in rows and just completing an assignment, does that guarantee that you're learning and thinking, Brianna?
No.
Sitting in a row just doing a worksheet guarantees you thought? Oh, I highly disagree with that assessment. I cannot tell you how many times I have seen students write stuff down without thinking and they didn't actually learn a single thing. That happens all the time. My wife has seen in her classrooms when she was teaching high school social sciences. I've seen it in my classrooms. Miss Williams and I have both seen it. Just because you do a worksheet doesn't necessarily mean you thought and you've learned. And so I don't want you just on task. I don't want to just curb behavior issues. I want you thinking and learning. So yes, I don't disagree with that study, honestly, that sitting in rows reduces behavioral issues. But I want more because you're an intelligent human being. And I want to equip you to think and to learn. So these are the things, like when people send you data and send you studies, you need to be able to investigate and say, is this valid? And honestly, I get it. Not everyone is sending studies to other people. Please start. Like when you hear claims of something, ask for the data, ask for the study that provided that data, and push on it. You awake with me, Walter? Okay. All right, so continuing from there, on to the DYU. Anyone have a guess what's going to be on this DYU? So a lot of experiments, all the stuff we went through. Specifically, does anyone know something that you could have looked at to say, hey, this is what's going to be on my DYU? That yellow sheet. Remember, that whole point of that proficiency scale is to give you a set of this is what we're going to be assessed on, right? Like I'm telling you up front. Now, I will say this is going to be more heavily focused on experiments because we've already done one on observational studies, but remember I told you that we've got to continue working with observational studies, so it's going to be on there a little bit. However, the fact that we're asking that question today, the day of the DYU, really makes me worried. I'm not going to front. Okay. So we're going to finish up this does SAT prep improve our scores, then we're going to do a DYU, so we're going to do some review things within that assignment. And then we're going to practice for the rest of today, okay, afterwards. So, at this point, hopefully you have mastered everything here. We should know categorical versus quantitative data in questions and variables. We should know statistical versus non-statistical. We should know when bias or confounding is an issue in a study. We should be able to determine if a study shows correlation or if it can establish causation, right? Like that's the whole point of these studies. That's foundational. We got to know this, right, Walter? Can you stand up, move around a little bit, get the blood flowing? Okay, remember, the focus though has been, at this point, explanatory response variables, experimental units, treatments, and then being able to identify what type of study it is, sources of confounding, and ways to reduce confounding. So remember, these are the terms that we need to be able to apply very heavily. Okay, so I want to point this out. Please have this task sheet out. This is the, does the SAT improve scores, or does SAT prep improve scores? That's what we're looking at. Okay. So remember, I made the recommendation that I would not cut out. We're not going to cut out the sheets or the, what are they, the conclusions, because, well, that would just be a lot of cutting, and I want to focus on the learning side of things. So what I'm going to do is, I'm going to give you all about 4 minutes as a small group, and just for the sake of time, let's just stay in our seat for now. We'll get up to our vertical surfaces in a little bit. I want you to get as far as you can in looking at these contexts, right? Actually, let's do this first. Yeah, let's do this. Right here. Some students at your school claim that taking an SAT prep course will help improve their SAT scores. And so we're designing a study that will help discover if this claim is true. A couple of things I want to point out is, we're looking at 6 proposed studies to investigate the question of the day. And we find that the mean SAT score of students who took the SAT prep course is significantly higher than the mean SAT score of students who didn't take an SAT prep course. And we're going to look at this study design. A couple of things, before you even start doing what this assignment asks you to do, I want you to do this. I want you to identify as a small group what the experimental unit, or explanatory and response variables are. That's something that's going to be on your assessment. So explanatory and response variables. I want you to identify your experimental units. And I want you to identify your treatments. And I would say treatments if there are any. I want you to identify those for number 1. So work with your small group for just a few minutes. Identify those 3 things for me, okay? Just talk at your groups. Think about what those would be. Alright, so let's look at it. And I will point this out. This is about how long, not saying we're there yet, but if we've been practicing with these things at all, with those check your understanding questions, this is about how long it should have taken to identify those things. So explanatory variables, what is explaining, or actually let's start here. Remember I told you all this. Don't start with explanatory versus response, just start with identifying the what? Start with the variables. Identify your variables first, and then think through what's explanatory, what's response. So variables, what is changing in the problem? What are characteristics can change?
The response.
Well, there is a response, but I'm asking, in this problem, in this context, what are the characteristics that can change? You can even look up here. What's a variable in this problem?
Whether they took the ACT.
Okay, so taking ACT class. Because I saw a lot of us write down explanatory and response, like, you don't have to tell me which one's explanatory, which one's response, but tell me what you wrote down as your variables. I feel pretty comfortable that Dean probably knows this. I need more of us engaging in this conversation. Taking ACT class, that's a variable here. Okay, what is another variable? Someone other than Dean. And other than someone who's talked a lot. And not in a bad way, just already shared ideas. What's another variable? What is something that can change?
The score.
Okay? Are people's scores changing? Okay. So we've got taking the ACT class, we've got the SAT score, those are variables. Alright? Now that you've identified what can change, which one is explaining the other? So, is taking the class explaining your score? Or is the score explaining the class?
The score.
The score explains the class?
The class explains the score.
Say, if you take a, so here's another way to think about it. Which one's independent, which one's dependent? Which one is affecting the other? Should taking the class affect your score, or should the score affect taking the class? Taking the class should impact your score, meaning it should explain. So, this is impacting the SAT score. By the way, it's very simple, but why do you think I wrote this statement down here? This is the what?
Confounded.
Not confounding. Yes, there's some causation in here, but think more about what I want when you, yes, it's a relationship, but I'd point out, like, this is my claim, this is my evidence and my reasoning. Isn't this my explanation for why I think this is explanatory and this one's response? I'm not saying that's a phenomenal explanation, but I just want you to see simple ways that you can show evidence and reasoning. And here's the thing, if you had flipped it, but you had said something along these lines, one thing explaining the other, do I still have evidence that you understand what explanatory and response are? I need you to show me these things. And remember, I always talk about go back to your what as part of your evidence and reasoning. Go back to your definitions. What is the thing itself? What is explanatory variable and response variable? Okay. So what are the experimental units? The seniors? Is it all seniors?
Yes.
Look at number one again.
No.
Because you'll have to actually look at number one.
All students
So all students in the senior only class, right? I see the confusion there. When we say senior only class, they're only talking about one class, like a class like this, not the senior class. So it's a class that only has seniors. That's what they meant by that. So I can understand that confusion. But experimental units, why are these experimental units? Notice I'm asking why, I'm asking for your what?
Reasoning.
Yeah, evidence and reasoning. Why would those be my experimental units?
And what the study is about.
That's not, so experimental units are not what the study's about. Good thinking, huh? That's a good idea, right? So these are the individuals, because remember, it doesn't have to be people. So it's not in the sample, it's the individuals, kind of like in the sample, like that'd be good evidence or decent start to evidence. But how do we know they're experimental units? These are the individuals, the treatments are applied to. Now, I will point this out. I will say this. I'll take it back a little bit. Brianna, you're a little bit closer than I initially said. That's my fault in the sample. Because these aren't really experimental units. Does anyone know why these are not experimental units, really?
There's no treatment.
There's no treatments. Did the researchers tell the people what to do? No. Okay. Now, if the researchers had told people what to do, what would the treatments have been?
What they told them to.
So telling them to do what? To either, not the SAT score, remember the treatments need to come in with the explanatory variable. We measure the response at the end. So what would the treatments be? Taking the class or not taking the class. So please remember, treatments need to come in with your explanatory variable. Treatments need to come in with your explanatory variable. Okay? So, hopefully that's a little bit of a recap for explanatory and response, experimental units, and treatments. But with that, I now want you to look at, because that should help set you up, these conclusions that might be able to be made based off of that study design. So can we conclude A, B, C, D, E, or F based on the study design for number 1? So this is where I'm going to give you 3 to 4 minutes. You might want to take notes. That's actually, you want time to take some notes on this, Brianna? Okay. I'm going to give you a couple minutes to take notes. If there's anything here to remember, but then we're going to get into the actual assignment or task. Katie, you with me? You live? Jock, can you pick up your card, or this card that is? Have you taken any notes to help you remember? That one that's on the ground. Katie, where's your card? I should have a third 9 somewhere. I need it. Need y'all to find your 9. You good? Tired? A lot of it today? Yes, sir. So again, please note, I'm just trying to give you some background, some help on identifying these details. This is not the task yet, but this should help us prepare for the DYU.
All of that is the conclusion.
No. We haven't done the conclusion yet. Remember, I was just saying we're trying to recap. Well, are you talking about what I wrote or what those answer choices are?
The answer choices.
So there's yeah. Oh, this is just us recapping explanatory and response variables, recapping experimental units, and recapping treatments. Here's the possible conclusions. So each of those questions should have one of these with them. Okay. All right. Oops, thank you. All right. I promise this is the last little task you're going to have to do sitting down for a little bit. We're about to get up and start moving because it looks like some of us need it. But I want you to take 3 minutes max, 3 minutes max. I want you to look at these conclusions and I want you to match one of those conclusions with number 1. So notice within these conclusions, like A says, for all students who have taken the SAT at your school, there is an association between taking an SAT prep course and higher SAT scores. B says for all students who have taken the SAT at your school, taking an SAT prep course causes higher SAT scores. So what I want you to think about is, can we make a conclusion about everybody at your school or not? Can you make a conclusion about an association or about causation? So 3 minutes, look at those different conclusions and match one of them with number 1. Find one of these that can go to number 1.
But it didn't tell us if they didn't do it bad.
But that's not the question. So like, if I want to make an inference about all students who have taken the SAT, what do I have to have?
How much was there?
No, think some more. Like, if you want to make a conclusion about when we say all, what should that make us think about? Population. If I want to make an inference about the population, what should I consider? What do I have to have? Look at number 2. What do you have to have? What type of sample? So if I want to make a conclusion about all students, then I need a... Okay. If I want to talk about an association versus causation, what do I need? And that's something we talked about the last couple of days. Well, I need you talking with your group, okay? Yes, ma'am. You're trying to figure out which of these conclusions can we go with under that. That one? Yeah, that's it. Okay. Which one are you thinking? D? E? That's an echo? Okay. Which one are y'all thinking? C or D? Okay. What are we thinking over here? Come together on the conclusion yet, Dalton? Alright, so let's look at this one. I've heard 3 different possible answers up to this point. I've heard C, D, and E. So let's investigate C, D, and E. Okay? So, when we look at, let's start with D. It's nice in the middle, and then we'll play around from there. When we look at D, what are some of the key things that kind of jump out at us?
For the students in this class.
Okay, so for students in this class, okay, so why might some of us be thinking just for students in this class? Why? Because some people said E, so why would you say for students just in this class instead of for all seniors at your school?
They only asked the class.
So they only asked the class, so what are we missing in number 1 that makes it only students in this class and not all seniors?
Yeah, are the students in the senior class, senior only class?
So remember, it's all the students in the senior only class, right? So it's only one class. So my question is, if we look at these 2 differences, right?
E is saying for all students, for all seniors in the school.
So do you think it could be E?
No,
Why not?
because it's not, it said all, not only one class.
Okay, when we say that word all, Carly, when we say the word all, what should jump to our head? What's a statistical concept we've studied this year?
Population.
When did your name become Carly? Carly, what did Parker say? He's thinking it's what? Population. Guys, if I want to make an inference about the population, what do I have to have?
A sample.
What kind of
A random
sample?
sample.
I've got to have a random sample. Hey guys, do we have a random sample?
No.
No. So can I talk about all seniors at your school? No, right? So notice, those are things we want to be learning and paying attention to. I have to have a random sample to be able to make an inference about the population. That random sampling reduces bias. Okay, so what's the difference between C and D? Because C and D are the other 2 answers that I've seen. So one says an association, which, by the way, that word association is the same as saying correlation or relationship. And what does D say?
Causes.
Causes. So can we make a decision about cause and effect in this one?
No.
Why not? There's no treatments, there's no random, there's no random sample, but there's also no random assignment. Remember, if we want to determine causation, we've got to have random assignment to treatments. So number 1 is C. I can't make an inference about the population because I don't have a random sample. And I cannot determine causation because I don't have random assignment to treatments. Hopefully that sets us up well to do numbers 2 through 6. I'm going to give you maybe 10 minutes to do 2 through 6. Let's get going. Yes, sir.
Random assignments.
I'll come talk with you about it since you missed that. All right, go to your vertical surfaces. I want you to do 2 and then dash and put the conclusion there that you're going with. Number 3, this conclusion. Number 4, this conclusion.
Number 5.
Number 5, this conclusion.
Number 6.
And number 6, this conclusion. You're crushing it.
What about crushes you know YouTube?
Same. Yes, sir.
Wow, take the clothes off.
Okay, so Finney, here's the difference. Talking about it. Okay, so number 2. Let me put this up here. If I can get y'all to walk towards the front, that'd be great. Because I send the PowerPoint up this way. So walking up to the front, please. Thank you. Or sitting back because we're not listening to what I ask you to do. Okay, so this group said for number 2, so number 2, select a random sample of seniors from your school to participate in a study. Ask them whether or not they took an SAT prep course and divide them into 2 groups based on their answer to this question. So what's jumping out at us in number 2? What do we see there that might be important? We see a random sample. So what can we do if there's a random sample? Guys, it's all about inferences. What type of inference can we make if there's a random sample? We might do something with bias, but we can make an inference about the population, because what have we reduced? Bias. Okay? So remember, if there's a random sample, then I've reduced bias. Can you open the door? Yes, ma'am. I mean, it needs to be quick because we're trying to learn stuff.
In the cave.
Okay. Hey guys, random sample reduces bias so we can make an inference about the population. So what would be the population in number 2? All seniors, right, from the school. Okay. Can we make an inference about causation this time though? Why not? Because there's no treatments, no random assignment to treatments. So I agreed with, I said E. For all seniors at your school, there is an association. Guys, we need to recognize, if there's no random assignment to treatments, can I determine causation? No. There's no random assignment to treatments, so there's no causation here. But I've reduced bias to see the population. Number 2, what should jump out, or number 3, what should jump out at us? Random sample. But what's the population in this case? Students who have taken the SAT from your school. So who can I make an inference about? All students who have taken the SAT at your school. Can I make an inference about causation here? No, because there's no what? Treatments. More importantly, no random assignment to treatments. So we need treatments, 100%. But we need random assignment, because what does that random assignment do? It is really, really important for reducing, well, it reduces confounding to establish causation, right? It's reducing confounding to establish causation. Remember, it makes your groups balanced, right? That random assignment balances your groups out. So A, for all students who have taken the SAT at your school, there is an association between taking the course and higher SAT scores. Number 4, get all students in a senior-only class participate in a study. Randomly assign half of the students to take an SAT prep class. Have the remaining half not take the class. So, what kind of conclusion can we make? Can we make an inference about the population? No, why not? There's not a random sample. Guys, there's no random sample, so there's no population I can make an inference about. Can I make an inference about causation? Why? Not just treatments. Randomly assign half of the students. Now random assignments reducing what, Annalise? What's the random assignment going to reduce? Well, we randomly assign 2 treatments, but what's that going to reduce? The effects of something. Confounding. We got to know that. We got to immediately recognize, hey guys, if we're randomly assigning, we're reducing the effects of confounding. So we can make an inference about causation, okay? So only for the students in this class, notice this is D, take an SAT prep course, causes higher SAT scores. Alright, number 5. What jumps out at us in number 5? A random sample and randomly assigning. So I can make in what kind of inferences here? About the population and about causation, right? About those treatments. So what population do we have in this case? All seniors from your school. So F. So a lot of us were really close on this one, but notice for all seniors at your school, taking an SAT prep course causes higher SAT scores. We got to recognize random assignment reduces confounding so we can determine causation. Finally, number 6, random sample. What else should jump out at us? randomly assigned, so we can make an inference about population and causation. So for all students who are taking the SAT of your school, taking an SAT prep course causes higher SAT scores. So the only edits I think for this group would have been this is F and this one is E. And now I want to make some quick notes. So you can update that in a second. Can you hit the lights for me? Don't take a seat yet. I need us engaged. Walter? All right, thank you. So hold on. Y'all can update these in a second. I need us to pay attention to these quick notes. Right here, we need to recognize if there is random assignment, so I'm going to do a two-way table here. This is the key. And there is random sample. So yes. Let's start with no. And yes. No and yes. So if there is not a random sample and there is not random assignment, what inference can I make? Or can I make an inference? So no
Causation.
inferences about, so if there's no random assignment, no inference about what? Causation. If there's no random sample, no inference about population, right? So no inferences about population or causation. Okay, so let's look here. What if there's no random assignment, but there is random sampling? So I can make an inference about population only. Okay, we need to recognize that. Now here, what if there's random assignment, but not a random sample? Inference about causation only. Okay. What if there's random assignment and a random sample? We have inference about population and causation. Now, last thing I want to point this out. Which of these sections is normally where we are if we're looking at an experiment? So yes to random assignment and no to random sample. This is what an experiment usually is. Because remember, do we care about the population in experiments usually? No, we only care about treatments and causation. Which of these is what is usually an observational study? Inference about population only. Okay? This is a very rare case where you have, look, so is it possible to have an inference about population and causation? Yes, you just have to have random sampling and random assignment. And honestly, there are some studies that do this. They just suck. Because I can't really make an inference about population or causation. Sometimes we do studies like this to tell us when we need to go deeper. All right. Grab a seat. Take what notes you need to. And then we're going to start the DYU in just a few minutes. Just one page, but...